There's a lot of different ways to do text analytics. There's three main components. One is auto-categorization. What is the document about? Then there's data extraction. You pull out important information. And then there's a range of supplemental. Tom Ramey, author of Deep Text. Auto-categorization is done either with machine learning or with a categorization language. Machine learning is the earliest part that was developed. It's basically where you use the software to look for patterns in text and use that to build your categorization rules. So machine learning is where you take a set of documents that are good sample documents for a particular category in a taxonomy, say, and you use the machine then creates a statistical signature based on those training sets that you gave it. And it can be done with straight statistics, Bayesian statistics, and vector space representations and so forth. Any new content that comes in, you compare it with the signature of the training sets that you've done. And if it's close enough, you tag it with that particular category. The problem with machine learning is it's not very accurate. Documents aren't about one thing. They're about a bunch of things. And so you get a lot of noise in straight machine learning approaches to text analytics and specifically to categorization. What I do mostly is working in the area of categorization languages. One of the splits in text analytics is between technical people and linguistic people. And machine learning is mostly technical people. Categorization language are mostly linguistics people. So categorization language then is based on starting with just simple Boolean logic, and, or, and nots. If you see this word and that word, but not this one, then it's about such and such. That's a start, but most software also has more advanced operators. The most important ones are things like near or near within a given order, or things that are in the same paragraph or same sentence. And that gives it a much bigger power, or much greater power. So the problem with machine learning, and also, by the way, why the early search engines were so bad, is they just treated the document as a giant bag of words. And so if you find these two words in the same bag, oh, well, that's important. Well, usually it's not, because if the words are separated by 30 pages, that's not important. So the categorization language gives you the ability to say, okay, only count these words if they're in the same sentence or the same paragraph or within 7 words, or they follow certain other. So you get to build much more advanced, much more accurate categorization rules. All text has some kind of structure. It's made up of words. It's made up of sentences. It's made up of paragraphs. And even more importantly, typically documents have sections in them that are designed for specific purposes. So if you just dump all that into a giant bag, you're not going to get very good results. One of the things that we've had a great deal of success with is building content structure models, capture the structures of the different documents and document types. It's each type tends to have its own structural model. And so we build these content structure models, use that to look at words that are particularly important in particular sections. Some sections are, executive summary, abstract, conclusions. These kinds of sections you want to treat differently than the body of the text. And there's other kinds of sections as well, like there are sections that have data in them that you want to capture. There's structures that you want to ignore. If the section is, acknowledgments or see other, you don't want to use that in a categorization model. And so one of the things that, so what I'm talking about mostly is sort of the deep text approach, but it's also got a certain dynamic capabilities or aspects as well. You don't have to have a formal document structure in order to build these content structure models. You can use certain keywords to focus on. You can use headings of various kinds. This was a project done with the Department of Transportation. And what we were tasked with was building the ability to figure out what these work orders were for, because their work orders, what was the problem that they were designed to fix, and these work orders could be anywhere from 5 pages to 500 pages. And most of it was not particularly useful for trying to figure out what the work order was for. And so what we quickly doing an analysis for the content structure model, these two sections that are highlighted on the right were the two sections that all you had to pay attention to was those two. And you could ignore 495 pages of the document when you're trying to figure out what it's about. So machine learning, typically you get 65 to 70% accuracy. We were able to get 95% accuracy and above using these content structure models. It works 100 times better than asking authors to add keywords to their documents so that the search engine can find them. It's not the job of the author to figure out what keywords should be used to enable somebody else to find the document. So they tended to resist it. We have horror stories of going into enterprise and finding that this one person tagged every single document he ever worked on with the same keyword, things like that. So they resist it, and with good reason. As I say, that's not their job.